Alright, we're going to deal with some proportions here in this video. Now recall that a proportion is basically two fractions set equal to each other. So whatever this fraction is on the left, it has to be in the same ratio as the fraction on the right. So we could have 1/2 is the same as 2/4. And recall that we can check whether something is in proportion by using cross multiplication. If we multiply this way, 2 times 2 gives me 4. That has to equal the other direction. And in this case, 4 times 1 is 4. When you cross multiply, if they are the same, you have a true proportion. So as we go through, we are going to find out whether or not are these ratios. I should say, are these proportional? Are these two ratios proportional? And I'm going to check this by saying, are they equal? When I cross multiply, does it work? So I'm going to start here. I'm going to go this way. 20 times 20 gives me 400. Is that the same as when I take 100 times 4? Well, 100 times 4 is 400. Since they are the same, the answer is yes. These are proportional. Same thing here. I'm going to go this way. 18 times 11 and 99 times 2. When I get that, I end up with 198 equals 198. Boom. Works. In this one, I cross multiply, and I end up with 4,050 equals 4,200. Hopefully you say equals the wrong word. The answer to this is no, they are not proportional. Number 4, we invite decimals to the party. Hey, that's all right, no big deal. We still cross multiply, so the 1.225 multiplies by 8. 7 multiplies by 1.4. I get 9.8 equals 9.8. Yep. These two are proportional. Cross multiply. I get 14,000 equals 140,000. No, 3 zeros, 4 zeros. Those are not the same. We also can play when we have, what's the word I'm looking for? Scientific notation. Remember, if you don't see an exponent, it's automatically a 1. So first things first, when I go this way, 2 times 2.5 is 5. Times 10 to the 3 plus 1 is 4. Now, does that equal, let's go the other direction, 5 times 7 is 35, times 10 to the negative 2 plus 6 is 4. Well, now we kind of have two pieces to look at. These are the same, so that's good, but 5 is not the same as 35, so this answer is no. These two pieces are not equal. This is not a true proportion. Okay, so we'll do another one. We'll go this way. 1.5 times 4 is 6, times 10 to the 5 plus 2 is 7. Does that equal 3 times 2 is 6, times 10 to the 2 plus 5 is 7? Yes, these are proportional. Okay, now on this one, before I really get started, I'm going to just rewrite it a little bit. So when I see million, million makes me think 10 to the 6th. 1,000 makes me think 3. 2,000, 10 to the 3rd, and 4. So now I can say, okay, do these work? Are these the same? So when I cross multiply, 2 times 5 is 10, times 10 to the 3 plus 3 is 6. The other direction, 4 gets multiplied by 40, that's 160, and then I just have times 10 to the 6th. Well, the 10 to the 6th is the same, but 160 is not the same as 10, so no, these pieces are not proportional. Same concept here, I have 8 billion. That's 8 times 10 to the 9th over 50. And I have 305,000. That's times 10 to the 3rd over 3.5. Are these equal? So I cross multiply. And I lost my train of thought here on my paper. I have 15,250 times 10 to the 3rd. Does that equal when I go this direction and I get 28 times 10 to the 9th? Now you might say, well, these aren't in scientific notation. Well, no, they're not. But I don't even need to put them in scientific notation to know that these are not the same. I mean, for this one, if you moved it 1, 2, 3, 4, you would add, that still only gives you 10 to the 7th. That's not 10 to the 9th. And this one's going to go, this is 2.8 times 10 to the 10th. This is 1.525 times 10 to the 7th. Those are not the same. The answer to this is no. And let's do another one of these. 1 trillion, 1 times 10 to the 12th over 8 million, 8 times 10 to the 6th. Is that the same as 0.5 times 10 to the 12th over 4 times 10 to the 6th? Well, I go this way and I get 4 times 10 to the 18th. I go this way and I get 4 times 10 to the 18th. Yes, those are the same. All right, now let's go ahead and solve some proportions. So now if we have an unknown, your method is still the same. We're still going to cross multiply. X times 3 gives me 3x. That has to be equal the other direction, right? By definition, two ratios are proportional if the cross multiplication is equal. Okay, so to get this, the equal sign breaks your equation into two equal parts. We want to get x by itself. Well, this is 3 times x, so I'm going to divide each side by 3. Because 3 divided by 3 is 1, I'm left with 1x. 72 divided by 3 is 24. So my missing piece is 24. All right, cross multiply. 5x equals 606. Equal sign breaks it up. I divide both sides by 5, and x equals 121.2. Now we have a decimal. That's okay, we can play with decimals. 6.3x has to equal the other direction. 4.61 times 4.7 gives me 21.667. Again, the equal sign divides this in half. I'm going to divide both sides by the number in front of my variable, and when I round to the nearest tenth, I get 3.4. All right, now this one really kind of looks ugly, and before I do anything else, I'm just going to rewrite this. Okay, so I have x over 4 times 10 to the negative third. 50,000 is 5 times 10 to the fourth, right? Move it 4 places, scientific notation. And then I have 0.4 times 10 to the third. And you might say, well, Becky, that's not scientific notation. You're right, it's not. But I'm not worried about it right now. Everything is in some times 10 to some dealio, and I'm good with that. So I'm going to go this direction. 4 times 5 is 20. Times 10 to the negative 3 plus 4 is 1. So that's that direction. Now that has to equal the other direction, which is 0.4 times 10 to the third times x. And this is where it kind of may be a problem that you have using x as the time sign, because we have x's in the problem, we have x's in the time sign. You can always change your variable, get rid of x and use something else. Or I see how I put my variable in parentheses, right? Or we could even be super creative and just use a different color, right? Woo, look at that. Either way, doesn't really matter how you decide you want to do this. We need to divide both sides by the piece in front of the variable. So these cancel out. I'm just left with x, going up here. Now, when I take 20 and I divide it by 0.4, I get 50 times 10 to the 1 minus 3 is negative 2. So if I take 50 and I have, here's my decimal, I'm going to move it 2 places to the left, my final answer in standard form is simply 0.5. So after all that business, we get 0.5. Seems kind of crazy. Number 5, I'm going to do the same thing and rewrite this. Now, 8 tenths is just 0.8 over x. 8 million is 8 times 10 to the 6th. 8 trillion is 8 times 10 to the 12th. So if you want, you could put 0.8, put that in scientific notation, but I'm going to leave it just like it is. When I cross multiply, 8 times 0.8 gives me 6.4. So I have 6.4 times 10 to the 12th equals 8 times 10 to the 6th, or I'm going this direction, times x. So I divide both sides by the piece in front of the variable. So these go away, and 6.4 divided by 8 gives me 0.8 times 10 to the 6th. Now that's ugly. You can't leave it like that. You either need to change it to scientific notation correctly or change it to standard form. So 0.8 is less than 1, so it's going to go down. So if I go 1 here, my exponent's going to go down. I would have 8 times 10 to the 5th is an acceptable answer. Okay, or 800,000, either one. And last problem, it's already in scientific notation for us. So let's go ahead and cross multiply. I have 3.4 times 10 to the negative 4th times x equals, when I go this direction, 5 times 8.21 gives me 41.05 times 10 to the negative 6 plus 2 is negative 4. I divide both sides by the number in front of my variable. And that leaves me. Now, when you look at this on the side, hopefully you see these are the same. If you have times 10 to the negative, I mean, that's like having 2 over 2. They cancel out, they're just 1. So I just take 4105 divided by 3.4, and I end up with, rounded to the nearest tenth, 12.1. And that is the end of your proportional video.